सो देखते हैं आज के क्लास में एप्लीकेशन ऑफ एनएलएम। एप्लीकेशन ऑफ एनएलएम, एप्लीकेशन ऑफ न्यूटन्स लॉज ऑफ मोशन। एप्लीकेशन ऑफ एनएलएम, एप्लीकेशन ऑफ एनएलएम, एप्लीकेशन ऑफ न्यूटन्स लॉज ऑफ मोशन. So what are the applications of NLM? First is tension in the block. First is tension in the block. F is the force applied. F is the force applied. F is the force applied. M is the mass. Mass of the block is M. Length is L. This is X. So mass is M, this is X, this is L. So what would be the tension? What would be the tension at this point? What would be the tension at this point? What would be the tension at this point? Tension at this point is equals to how much? T tension at this point, T equals to mass of the shaded portion into acceleration. Tension equals to mass into acceleration. T equals to how much? T equals to mass into acceleration. So mass of the shaded portion into acceleration. Mass of the shaded portion equals to how much? Mass of the shaded portion equals to lambda into x. Mass of the shaded portion equals to lambda into x. Lambda is mass divided by length into x. T equals to how much? T equals to mass divided by length into x into a. That is the tension. T equals to how much? T equals to mass per unit length into x into a. That is the tension. Or T equals to how much? Mass into acceleration, that is F into x divided by L. T equals to how much? T equals to F into x divided by L. That is the tension. T equals to F into x divided by L. That is the tension. So next is M is the mass, L is the length. So this is x. So here force applied is F. F is the force applied. F is the force applied. F is the force applied. So tension equals to how much? So tension equals to how much? Tension equals to mass into acceleration. Tension equals to mass into acceleration. So as tension equals to mass into acceleration, so mass equals to how much? Mass of the shaded portion equals to mass of the shaded portion equals to lambda into remaining separation is L minus x. So this is mass per unit length. So this is mass per unit length into L minus x, that is the mass of the shaded portion. So this is mass per unit length into L minus x into A. So tension equals to how much? Tension equals to mass into acceleration, that is F into L minus x divided by L, that is the tension. T equals to how much? T equals to F into L minus x divided by L, that is the tension. T equals to F into L minus x divided by L, that is the tension. So when force is there at both the side, so this is F1, this is F2. So this length is L. If this length is L, this is x. This is L minus x. So Tx equals to how much? Tx equals to how much? Tx equals to F2. Tx equals to how much? Tx equals to F2 into L minus x by L plus F1 into x divided by L. So Tx equals to how much? F2 into L minus x by L plus F1 into x by L, that is the tension. So application of NLM, that is the tension in the block formula. Second bit, connected bodies. Connected bodies. This is M1, M2, M3. Force applied is F. F is the force applied. F is the force applied, A is the acceleration. So connected bodies, F is the force applied and A is the acceleration. So M1 is equals to, so this is mass M1. For mass M1, so this is force F and this force is F1. This force is F, this force is F1 and this is acceleration. As this force is F1, this is also F1. Action, reaction. For M1, F minus F1 equals to how much? Equals to M1 into A. F minus F1 equals to M1 into A. For M2, this is F1, this is F2. This is F1, this is F2. This is F2, F1, this is F2. This is acceleration. F1 minus F2 equals to mass into acceleration. This is second equation. For M3, For M3, this is M1, this is M2, this is M3. For M3, this is F2 and this is A. F2 equals to how much? F2 equals to M3 into A. So adding 1, 2, 3. Adding 1, 2, 3 we get. Adding 1, 2, 3, F1 gets cancelled. F2 gets cancelled. So F equals to how much? F equals to A whole M1 plus M2 plus M3. A equals to how much? A equals to F divided by M1 plus M2 plus M3. That is acceleration. A equals to how much? A equals to F divided by M1 plus M2 plus M3. That is the acceleration. So that is motion of connected bodies. Next is uniform rope. For uniform rope, length of the rope is L. L is the length of the rope and this is X. This is the saddle portion. So what would be the tension? So find the tension. Tension T equals to how much? T equals to mass of the saddle portion into G. T equals to how much? Mass of the saddle portion into G. Mass of the saddle portion equals to lambda into X. Lambda is mass per unit length into X. That is the mass of the saddle portion. T equals to how much? Mass of the saddle portion is mass per unit length into X into G. That is the tension. That is the tension. Second, rope is accelerating upward. Rope is accelerating upward. As rope is accelerating upward, this is M by L X G plus A. As rope is accelerating upward, so rope is moving downward. So T equals to mass per unit length X G minus A. That is the tension. T equals to mass per unit length into X into G. Rope is moving upward, so that is M by Lx G plus A. Rope is moving downward, so that equals to M by L X G minus A. That is the uniform rope. नेक्स्ट इज ब्लॉक सिस्टम न्यूमेरिकल या फिर वेज ब्लॉक न्यूमेरिकल. वेज ब्लॉक न्यूमेरिकल. नेक्स्ट इज वेज ब्लॉक न्यूमेरिकल. For the wedge block numerical, when M does not slide relative to wedge. First point, when block M does not slide. When block M does not slide relative to wedge. First point is wedge block numerical when M does not slide relative to wedge. So this is the wedge. So this is the wedge. Wedge mass is capital M. This is small m. This is capital M. This is small m. So this is theta. When block M does not slide relative to the wedge. F is the force applied. F is the force applied. As F is the force applied, so every action has equal and opposite reaction. Weight is mg. So this is normal reaction. N is the normal reaction. So this theta, this is also theta. This is theta. This is n cos theta. This is n sin theta. So this is force, this is mass into acceleration. Pseudo force equal opposite force applied. So this is also F, equal opposite force, that is also mass into acceleration. This is also F. So n sin theta equals to how much? N sin theta equals to F, and n cos theta equals to how much? N cos theta equals to mg. N sin theta is F, n cos theta equals to mg. So this is m into a. So sin theta by cos theta, that is tan theta. Tan theta equals to a by g. Sin theta by cos theta is tan theta. Tan theta equals to a by g. A equals to g tan theta. A equals to g tan theta. A equals to g tan theta. That is the acceleration. A equals to g tan theta. A equals to g tan theta. When block does not slide relative to wedge, A equals to g tan theta. When block slides with respect to wedge. when block slides with respect to wedge. This is capital M, this is small m. So this is the pulling force. This is the pulling force. This is the M into A. So this is mg. Weight is mg. N is the normal reaction. Weight is mg. N is the normal reaction. N is the normal reaction. So this is mg. So this is theta. This is 90 minus theta. So this is ma cos 90 minus theta. Ma cos 90 minus theta is ma sin theta. So this is mg cos theta. So this equals to n plus ma sin theta, n plus ma sin theta equals to how much? Equals to mg cos theta. N plus ma sin theta equals to mg cos theta. So if n equals to 0, if normal reaction equals to 0, ma sin theta equals to how much? Equals to mg cos theta. A equals to g cos theta by sin theta is cot theta. A equals to g cot theta. A equals to how much? A equals to g cot theta. That is the acceleration when block slides with respect to wedge. When block slides with respect to wedge, that is A equals to how much? A equals to g cot theta. A equals to g cot theta. That is the acceleration. Next is gas balloon problem. Gas balloon numerical. For the gas balloon numerical, when this is the balloon, m is the mass, weight is mg, T is the tension, weight is mg, balloon moves in downward direction. Initially, balloon moves in the downward direction. So we can write equation mg minus t equals to how much? Mg minus t equals to ma. That is the first equation. When some amount of masses gets released, when some amount of masses gets released, when some amount of masses gets released, capital M minus small m. When some amount of masses gets released, so this is m minus m into g. This is the T. So this is the tension, and this moves in upward direction. This moves in upward direction. So this can be written as T minus m minus m into g equals to m minus m into a. This is equation 2. This is equation 1. This is equation 2. So adding 1 and 2. So adding 1 and 2 we get, adding 1 and 2 we get tt gets cancelled, mg gets cancelled. So capital M mg gets cancelled. So adding 1 and 2, mg equals to how much? Mg equals to, small mg equals to how much? Small mg equals to, small a is taken as common, that is capital M minus small m plus capital M. So a equals to how much? Acceleration equals to, acceleration equals to how much? Acceleration equals to small m g divided by twice capital M minus small m. So that is the acceleration. That is the acceleration. Acceleration equals to small mg divided by twice capital M minus small m. That is the acceleration. That is gas balloon numerical.